Welcome to Penrose Learning, where we make understanding easy.
You start by preparing the environment and getting a model. Create a virtualenv, pip install torch, torchvision, OpenCV, and NumPy dependencies match. Next, choose a pre-trained detector, YALOV 5 or faster RCNN, and download the weights file. This gives you valid anchors and classes. Once done, confirm device availability. If you have CUDA, set device to CUDA. 0, make sure drivers and CUDA versions match. Then, write a small loader to read an image into a NumPy array and convert it to a tensor. Now you handle preprocessing and run inference. Resize or letterbox the image to the model's expected shape, normalize using the model's mean and STD, and convert OpenCV BGR to RGB. Then transpose to CHW, add a batch dimension, and cast to float 32. Scale pixel values to 0, 1 if required. Pass the tensor to model. Eval, and call model image tensor. To device. After you get raw outputs, apply the model's confidence threshold and non-max suppression to filter overlapping detections. Finish by mapping detection coordinates back to the original image size, then draw bounding boxes, class labels, and confidence scores so you can validate results visually. Save the annotated image or stream frames to a video file. If you need deployment, export the model to ONGs or TensorRT and benchmark. Make sure to also serialize detection metadata as JSON for downstream tasks. If outputs look wrong, check preprocessing alignment, correct class ID mapping, and that you loaded matching weights and model config. This usually fixes most issues.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.